In this video, we will be explaining how to solve question 6 of the 2012 FRQ, along with question 76 through 78 of the first multiple choice. So to start off with the question of the 2012 FRQ, the question states that for when time is between 0 through 12, a particle moves along the x-axis. So the velocity of the particle at time t is given by the function v of t equals cosine pi over 6t. It also states that the particle is at position x equals -2 when the time is 0. So now let's move on to part A of the question. So for part A, it asks that for when time is in between 0 to 12, when is the particle moving left? So to solve this question, we need to know a crucial concept, and that is the particle is moving left when the velocity is a negative, and that the particle is moving right when the velocity is a positive. So in this case, we are just trying to find when the velocity is a negative number. So to find that, we set the velocity equation, which is cosine of pi over 6t equals 0, which gets us 3 and 9. So using 3 and 9, along with the boundary values, which is 0 and 12 here, we can set up 3 different intervals. So with these intervals, we can try to find whether the values in between these intervals are going to be positive or negative. To do this, we can simply plug in any value within the interval back into the velocity equation. So for example, we can plug in any value from 0 to 3 into the velocity equation, and we will get a positive value. So we can determine that the velocity from 0 to 3 will always be positive, and by plugging in more values from 3 to 9 and 9 to 12, we can determine that from 3 to 9 it will be negative, and from 9 to 12 it will be positive. So with this information, we can therefore conclude that the particle is moving left from 3 to 9. So now let's move on to part B of the question. So part B states that write but do not evaluate an integral expression that gives total distance traveled by the particle from t equals 0 to t equals 6. So to solve this problem, you will have to know the concept of total distance traveled. So total distance traveled, similar to displacement, is the integration of the velocity. But however, total distance traveled does not account for direction. So it means that we have to absolute value the velocity, because we have to add both of these areas together instead of adding the positive one and subtracting the negative one from the positive one. So to sum it all up, the integral expression of the total distance traveled will be the integral from 0 to 6 of the absolute value of the velocity, which will be cosine of pi over 6t. So now, moving on, we have part C. So part C states that find the acceleration of the particle at time t. Is the speed increasing or decreasing or neither at t equals 4? Explain your reasoning. So to start off this problem, let's first find the acceleration of the particle at time t. So to find the acceleration of the particle, we will need to derive the velocity, which is cosine pi over 6t. So with the derivative of that, we get negative pi over 6 sine of pi over 6t by chain rule. So with this equation over here, we can determine if the speed is increasing or decreasing or neither at t equals 4. So basically, the speed is increasing when acceleration and velocity have the same signs, decreasing if the velocity and acceleration have different signs, and neither if the acceleration is 0. So with this in mind, we can plug in 4 into both the acceleration equation and the velocity equation. So with that, we will get negative root 3 pi over 12 for acceleration and -12 for velocity. So as you can see, both have negative signs. So therefore, we can conclude that the speed is increasing because the velocity and acceleration have the same signs. So last but not least, we have part D of this question. So part D says to find the position at t equals 4. So basically, to find the position, we can just integrate the velocity and add negative 2 to the front because it says that the position is at negative 2 when time equals 0. So with this, we can just integrate this, and we'll get negative 2 plus 6 over pi sine of pi over 6t from 0 to 4. So with this, we can pull out the 6 over pi here, and then we'll use the fundamental theorem of calculus, the second one, and we will get negative 2 plus 6 over pi times sine of 2 pi over 3 minus 0. So with this, the 0 can just be ignored, and we will get negative 2 plus 6 over pi times root 3 over 2. So this will get us, ultimately, negative 2 plus 3 root 3 over pi units. So this ends the explanation to question 6 of the 2012 FRQ.
So number 76 asks us to find the derivative of f of x equals e to the 2x over 2x. So since this part of the multiple choice is graphing calculator required, we're going to use a TI Inspire to solve number 76. Okay, so now that we have a graphing calculator, we can use it to find the derivative of e to the 2x over 2x. So to find the derivative, we first have to plug in the function of the derivative, which is on the calculator. So to do that, we have to go to Menus, Calculus, and then Derivative. So now we just need to plug in e to the 2x over 2x into this function. To do that, we have to go to this button and then press the fraction button, and if it gives us a fraction. And then from here, we just plug in e to the 2x over 2x, which is basically... So from here, you can realize that you can simplify 1 over x minus 1 over 2x squared into 2x minus 1 over 2x squared. So unfortunately, with this calculator, you can't really simplify this into one big fraction. And since it's multiplied by e to the 2x, we can go back to the worksheet, and then you see that it's e to the 2x times 2x minus 1 over 2x squared, which is what we got on our calculator. So for number 76, e is the correct answer. So number 77 asks us to find the point on the graph of the function y equals x cubed plus 6x squared plus 7x minus 2 cosine x, at which x changes concavity, or in this case, a point of inflection. Okay, so to find the point of inflection of this function, we first must find the second derivative of this equation. So now we go back to our calculator here, and then we just put in the derivative function of the equation. Press enter, and that's going to give you 2 sine of x plus 3x squared plus 12x plus 7. But since we have to find the second derivative, we have to find the derivative of this equation now. So we go back to calculus derivative, we press enter, and then that gives us 2 cosine x plus 6x plus 12. Okay, so now we have the second derivative of the graph. So to find the critical point, we have to set the function that we just found equal to 0, and then solve for x. So on a TI Inspire, there's a way to set this equation equal to 0, and then find the critical point. To do this, we have to go to Menu, and then go to Algebra, the zeros, and then just plug in the function. And then here, we have to remember to put a comma, and then x. This shows the calculator that it has to solve for the variable x. And we press enter, and we get negative 1.89. So that there is the critical point of the graph. Now, the question, number 77, asks us to find the point of inflection out of all the critical points on the graph. However, on this graph, there is only one critical point, and that we can deduce that it is the point of inflection. And then we go back to the problem, and then we see that out of all these D is the one with negative 1.89, which is what we got on the calculator. So for number 77, the graph of the function y equals x cubed plus 6x squared plus 7x minus 2 cosine x changes concavity at x equals negative 1.89, or D. So for 78, we're supposed to find f of 3 minus f of 0 given a graph lowercase f, and integral 3(1) f of x dx equal to 2.3, and uppercase f prime of x equal to lowercase f of x. Okay, so here we have the work that I did in order to solve number 78. So here we have f of 3 minus f of 0, and that can be changed to integral 3, 0 of f of x dx. And we can do this because of the first fundamental theorem of calculus, which states that if this f is continuous on the intervals 3, 0, and if this f is the indefinite integral of this f, then this is true. And if we go back to the graph, we can see that from 0 to 3, there are no holes or anything like that, so this graph is continuous. And if we go to here, f prime of x is equal to f of x, that shows that this f is the indefinite integral of f. So now that we know that the first fundamental theorem of calculus can be applied to this problem, we can move on to the next step. So now that we have an integral right here, we can separate this integral into two different separate integrals. In this case, 1, 0 integral f of x dx and integral 3 of 1 f of x dx. And we do this because in the directions of number 78, it is given that 3, 1 integral f of x dx is equal to 2.3. So now we know that this one here is equal to 2.3. But what about this one, 1, 0 integral f of x dx? How do we find it? Well, it's pretty simple. We know that integral is also known as area under the curve. And so if we go back to the graph and look at where 0 to 1 is, we can see that it is shaped like a rectangle. And then we just have to find the area of a rectangle, which is the area under the curve. In this case, the length is 2 and the width is 1. So 2 times 1 is 2. Now that we know what each integral is equal to, we just go back here, and then 2 plus 2.3 is equal to not 4, but 4.3. And then going back to 78 and looking at the letters, we can see that D is equal to 4.3. So the answer to 78 is 4.